In this video we're going to look at the more complicated motion equation. So far in the course you've probably done speed equals distance divided by time, and acceleration is equal to change in velocity over the change in time. So you need to know those on the specification, whereas this particular equation we're going to look at today will be given to you on the equation sheet, but you do need to know how to use it. So we're just going to spend a couple of minutes looking at how you use it. Okay, but first, these are the letters that you need to know, and this is important because the equations so far that we've done will all be using these letters. The letter U, this is new for today, the letter U is a velocity, but it's the initial velocity, whereas V, we've met before, that's the final velocity. So if you start off at 0 and then you begin to run and you run to a speed of 5 meters per second, we would say you have accelerated from an initial velocity of 0 to a final velocity of 5 meters per second. With that, if you covered a particular distance, we would say that particular distance that you've covered is S, and this S is more of a displacement. And however long it took you in a particular time, we would say that it took you a time of t, and that time is a little t, meaning a time that's elapsed. So all these letters you do need to know, because in the equation that we're going to look at, they are all present in that particular equation. All right, so using these symbols, using the symbols, write equations for acceleration and also distance. So acceleration, the increase in speed would be v minus u, because if you start off at 0 and end up at 5, then to work out the increase in speed, you would go 5 minus 0. So 5 minus 0 divided by t. So acceleration A would be equal to v minus u divided by t. Okay, so that's our acceleration, is increase in speed divided by time. Let's do another one. Our distance is average speed times the time. Well, our average speed, if you think about this, looking at this equation, the way to get an average is you take the two speeds, so the initial plus the final, and you add them together, u plus v, and then you divide by 2. So I've got a half here. So I've got half of u plus v, which is the average speed, multiplied by the time. So that formula would be for our average speed. Okay, now I'm just going to use these two. You don't have to do this on the specification, but some of you might want to be able to know how to do this. We're going to look at these two equations and we're going to try and combine them. Okay, but first of all, let's just rearrange this one. So I'm going to put the 2 up here and go 2s, and then I'm going to divide by u plus v and bring the u plus v down, which will leave me with t equals 2s divided by u plus v. And over here, I'm just going to rearrange it. I'm going to move the t up here and the a down. So I'm going to have t equals v minus u over a. Now with this, I've got two equations for t. So what we can do is put them both together. That's a classic physics trick you can do. So I'm going to say that 2s over u plus v must be equal to v minus u divided by a, because both of these expressions equal t. Now this is just a matter of some maths, depending on how confident you are. I've just moved u plus v up here, and I've moved a up here. So I've ended up with 2as is equal to v minus u multiplied by u plus v. And then using your quadratic equations, you can expand these brackets out, and you end up with v times u, v squared, and then you've got minus u squared minus uv. So the plus v squared, the vu minus uv goes, so you end up with 2as equals v squared minus u squared. Now that is the equation that you're given on the formula sheet. So you don't have to be able to do this, but I just thought you might like to see where we get the equation from. Some people find it easier when they know where it comes from. Okay, all that's left for us to do is to do some calculations. So just quickly look through these. You might want to pause the video and take some time over them if you're practicing. A student drops a ball from the top landing of an atrium, which is 7.2 meters above the atrium floor. How fast will it hit the ground, ignoring any air resistance, assuming the gravity is 10 meters per second squared? Okay, here's our formula: v squared minus u squared, whereas v squared we're trying to find, minus u squared is the initial velocity, which is 0 up here, and that's equal to 2 times the acceleration times the distance the ball drops, 7.2. So notice here I've put all my numbers in, and then I can just cancel this out. So 2 times 10 is 20, times 7.2 gives us 144. V squared equals 144. So if you put in your calculator the square root of 144, and you should end up with v equal to 12. If the student in question 1 throws the ball downwards at an initial speed of 5 meters per second, how fast will it hit the ground? Now, so this is the same equation, but instead of having 0 in for my initial velocity of u, I've got 5 in, so this is now 5 squared. Okay, be careful with the signs here. I've still got 2 times 10 times 7.2. But what I've just done, I've showed this in one step. This minus 5 squared, I would move over and have plus 5 squared, which is 25. So this whole thing would be equal to v squared. Ignore that minus 5 squared. I wanted to show you where it comes from, so it's gone over here. So v squared equals 2 times 10 times 7.2 times 25. Plus 25, which all equals 169. And if you square root 169, you end up with 13. So by throwing it down, it's with an initial speed of 5 meters per second, it's ended up hitting the ground at 13 meters per second. Okay, an A380 airplane has a takeoff speed of 77 meters per second. If it can accelerate at 1.2 meters per second, what is the minimum length of runway required? So let's put what we've got in. So we're going to have 77 squared, okay, which is v, minus the starting velocity. It has a takeoff, it starts from 0. 0 squared is equal to 2 multiplied by the acceleration, which we're given, times s, which we don't know. Okay, so rearranging all this, I've got 77 squared. 2 times 1.2 will be 2.4. So if I go 77 squared and divide both sides by 2.4, 77 squared divided by 2.4 is equal to 5929. Sorry, I've jumped ahead there. So 77 squared is equal to 2.4s. So 77 squared is 5929 is equal to 2.4s. Then I've divided through by 2.4. So 5929 divided by 2.4 gives an answer of 2,470 meters. And then finally, when the Airbus lands, it is travelling at 60 meters per second and can decelerate at minus 2.5 meters per second squared. How far will it go before it stops? So again, using the equation, this is 0 squared now, because what we're saying is that if it's travelling at 60 meters per second and can decelerate at 2.5, how far will it go? So the v squared minus u squared, so v squared minus u squared, we need to go from 60 down to 0, and that's going to be 2 is equal to 2 times the acceleration, 2.5 multiplied by s. So here we're going to have, I've got the minus signs will cancel in this eventually, so I've got 60 squared is equal to 3,600. 2 times 2.5 is equal to 5, so I do 3,600 divided by 5 and I end up with an answer of 720. Okay, so that's kind of 3 or 4 different examples, and possibly you won't be asked to do anything as difficult as that, but I just thought we'd go through some harder examples just in case.